Things I want to introduce today, just kind of talk about it. Just some little basic stuff like with this thing so you know how to do it. So that way tomorrow and the next couple days when we actually get into really heavy graphing for pre-calculus, you understand like what to do and you're not lost and you kind of understand how this system works. What you're looking at here is it's a Cartesian coordinate plane. Cartesian coordinate plane. Okay, it's a 15th century math concept by René Descartes, a French mathematician, poet, philosopher. We still use it today, right? Still used in every product you own. If you have a smartphone, if you have a television set, a computer, your camera, it uses the coordinate plane. It's kind of a crazy concept that it still uses it, even though it's a 15th century concept. We use it for GPS systems, to global positioning satellites to track where you are and to know, how to find your exact location. So how this works, there's a couple terms I want you to know before we get started here. We need to talk about the origin. Something you probably learned back in Algebra 1 days, or even maybe even pre-algebra in junior high. Where is the origin at?
In the middle.
Middle. Right in the middle, right in the center. Boom, it's right there. And you said it, what was it?
0,
0,
0.
0. Okay. We write it as coordinates, right? So that's the next thing. We have coordinates. Coordinates are 2 digits to get you anywhere on this graph. They're always in 2s. They're also called ordered pairs. Why are they called ordered pairs?
Because there's a pair.
There's a pair. Good. Two numbers.
Order.
What order?
X, Y.
X, Y.
Alphabetical. Yes. So alphabetical. X, Y. So these are the order that we have to write. Now, again, I know this seems silly. It's nice to review those things so you don't make silly mistakes when you have to go graph things eventually for me. Right? So if I give you an ordered pair like 0, 0, you go put the dot. How I remember ordered pairs, alphabetical order, right, X, Y, you have to pick an elevator, then you can go up and down in it. So what I mean by that, imagine that this whole grid is a big building, like a hotel, and this is the lobby. The x-axis is your lobby, right? So once you're in the lobby, and this is the center of the lobby, you have to pick an elevator. So numbers go to the right, and those count up, and then numbers go to the left, and they count down negatives. So you pick your elevator, then you can go up and down. So let's say I told you the coordinate -1, 7. Where would I draw?
Over and up.
Over and up. So to the left, and I'm up 7. 1, 2, 3, 4, 5, 6, 7. Yes. -1, 7. Now typically we label these with capital letters. So you can call it like A instead of putting the coordinate on the actual graph because it gets kind of messy. You can just put like .A. You can get even decimals. Decimals are totally fine. If I want to draw the coordinate for B, let's say I want to go over 3.5 and down 4.7. I can go draw that. So 3.5 over, 4.5 down. 1, 2, 3, 4.7 down. So there's B. Right? You can be in between. The grid is technically not supposed to be there. We just extended the lines for the x-axis and y-axis and it made the grid system. So you can get to anywhere. It's 2 number lines crossing. Now I've even been saying it. We have an x-axis and we have a y-axis. They're number lines that have been crossed over top of each other, and that's what made the grid system. They just extended the lines further. It's a pretty easy system, and you can get, it can give you a very visual aid for graphing. There's different types of visuals, right? Those are called the relations of math. You have coordinates, you have graphs, you have tables, you have mappings, you have inverse graphs and coordinates. There's like lots of different types of mappings and different ways of displaying data. It's one of those things like once you understand the purpose of it, then it all kind of starts to fall together. Now, most people, like once you see this stuff and you get kind of acclimated, you're fine. Quadrants, one of the last terms I want to talk about before we get into the real new stuff. Quadrants. Where's quadrant number 1? Give me a direction.
Top right.
Top right. Okay, top right. This is quadrant 1. Now when we number it, Roman numeral. We don't use the number 1 because then it looks like you're trying to draw a coordinate and you just didn't finish the number where you're trying to draw up there. So you use a Roman numeral. That's the area. That's the whole box where all these dots can be in. It doesn't include the axes. It's everything in between the 2 axes. So the whole grid, all the decimals and everything up there. Where's quadrant 2?
Bottom right.
Nope.
Top left.
Top left. Okay.
Just they go, yeah.
Yep, counterclockwise. The reason being is because of angles. When you draw an angle, you draw it towards the right. So this is how you draw angles. You draw the first line, it's called the initial ray. Then you open up counterclockwise and you draw, and that's why this would be quadrant 1. It's the first one you'd hit. Then as you keep opening counterclockwise, this would be the second quadrant you'd hit. If that makes any sense. That's why they number them counterclockwise. If you go to Europe, they teach that differently. We actually have a purpose because of angles and how they're drawn and how they're made. Military uses it, you know, if they for quadrant 1, 2, 3, and 4, they use the actual they actually use the directional bearing of it. So north is north, and then quadrant 1 is between north and east. That's the idea. But for math, it's pretty easy. Why I want you to know quadrants? It's nice to know the direction you're going. Where's the data found? Oh, it's in the quadrant. Okay, so you get this image of where all the data is found. It's a quick visual. Questions with that? Okay, so now, new stuff today. Because I know that some of this stuff seems kind of easy, right? And they're just like, well, what's the point? Like, what are we doing? New stuff. Okay, number 1, we have to talk about viewing windows. This is going to be new for you guys because viewing windows has to deal with if you have a graphing calculator. Graphing calculators are pretty handy little devices if you're lucky enough to have one. It's a huge help. I do not require that you buy one. We'll probably use Desmos in here if we ever have to graph things. It's just a free program online. But if you have, like in college, if you have to take a math course and they require you to have a graphing calculator, because it does happen if you guys are in pre-calc, so you're probably destined to be in an upper level math class at some point in college. If they require a calculator, I recommend TI 84s, 83s. Don't go anything bigger than that, like an 89 is, you can't even use it in college. They have new ones, Inspires, that color screens and stuff. But viewing windows, it's written like this. I'm making these numbers up, by the way. Let's make this a 12, not a negative. Okay, this is a viewing window. This is something you would actually type into a graphing calculator to modify the actual calculator itself. Let's get rid of the computer for now. Let's talk about the actual digits that are involved here. Okay. What you're looking at here, these are your x-axis numbers. So if you're going to draw the quadrant, what this stands for, the 3 is the minimum x that would be on your graph. The minimum x. It could be negative, positive, it could be any number. The 4 is the maximum x you'd hit. The max x. So the highest x you'd actually be hitting. And you're jumping by 1s. So the 1 is the unit spacing between them. So on your graph, this is what your graph would look like. That's my x-axis. It's telling me my lowest number, it's telling me my highest number, and it's telling me the units I have to put between the hash marks. I have 1 space between the hash marks. If the spacing was 2, I have to put 2 spaces between them. Okay? Does that make sense? Then, the second group here, the second one, is the same thing, but it's for the y-axis. So this means on the y-axis, I'm starting at 7 and going up to 12. And it's jumping by 1s. So this would be my 7, 8, 9, 10, 11, 12. So you can change the grid to whatever numbers you need. Maybe, and I know that seems weird, like why would you ever do that? Because maybe your data is just in that little region. Maybe this is month 3 to 4. So what is that, March to April on a calendar? So March to April, it's jumping by 1 month's intervals. Then maybe you're looking at hours 7 through 12 during the day. And you're just looking at the sales numbers. during that little time period. So you can kind of get a glimpse of like, is that the time where you're making sales? Maybe you're losing sales during that time. I always find it weird, like around this little community, the business is closed by like 4:30 or 5 o'clock. That doesn't help like students to get to a business. You're in school until 3 and you're in sports until 5 or 6. How would you go to the business then? I just find that really weird, but it makes sense. I mean, they have to have a certain hour of the day they have to be open so that people will have a normal time. So it's one of those things, like I understand the purpose of it, but again, practicality of it. But this is the idea by what we're doing. Do we understand the viewing window idea? Okay, we're going to use that later. That'll be a big thing when we get to graphing. Can we change the window so we can shorten up my graph so I don't have to have so many hash marks everywhere? I don't have to draw the entire graph when I don't need it. Maybe I'm just in the first quadrant, so we can narrow it down. Okay, last thing I want to talk about today. Absolute last thing. We have only a couple terms here. And this is going to take us into tomorrow. We'll do way more stuff with why you've been doing all these functions and factoring, all this good stuff. The last term today is intercepts. Intercepts. Let's talk about this word. Like an x-intercept or a y-intercept. Anyone know what the definition of an intercept means?
Two lines crossing each other.
Yeah, it's an intersection, right? It's a point of intersection. It's a point of intersection. Right? It's where things cross. It's shared points. It's a crossing. So if we get super specific about an intercept, and I say, okay, I want the x-intercept, right? The x, and they'll write it like this. The x-intercept, they'll abbreviate. That means, you know, when you're looking at your graph, so let me draw my graph here. I'm looking for the 2 dots where I hit the x-axis. So what are the 2 numbers where I hit?
-4 and 0.
-4 and 0. Notice how I wrote it. I didn't put commas between it. Commas make it look like it's a coordinate, right? I put a plus sign. You can name it like that, or you can give me the coordinates. -4, 0, and 0, 0. You write it like that. That's an x-intercept. Where did it hit the x-axis? It could just touch it like that 1, if you notice. It just dipped down, touched it, and went off, you know, up in the air. It's where it hits the x-axis. Okay? On that same picture, what's my y-intercept?
0.
Yeah, 0. Or if you want to write it as a coordinate, 0, 0. Where did I hit the y-axis at? Well, I hit it at 0, right in the middle. Maybe it hit it up higher. You have to tell me that number. Those are little things we're going to be getting in this next section when we start graphing. But I want you to understand the terminology before we get there. I don't want you to be lost because I'm using all these words and you're like, yeah, I don't know what you're even talking about. So intercepts, it's where it crosses, the point of intersection. Viewing windows, if we have to change the window, we'll do that to make sure the graph looks appropriate. So maybe we can super zoom in on a graph and see kind of what's going on. Because if you zoom too far out, everything looks like a straight line. If you zoom too far out, if you zoom in, maybe you'll start to see there is an actual curve to it. We'll start looking at that stuff. Questions with vocab. This, again, today was a light introduction. It was to introduce some basic stuff you already knew, kind of mix in some new stuff maybe that you're not familiar with. Maybe you knew all the stuff, and that's great. You're already ahead of the game a little bit. But then we're going to start looking at the homework and why we've been doing all the stuff we've been doing. Okay, are we good though? Okay, rest of it is yours. You can work on your worksheet. That is your worksheet P.8. It's due on Friday. Remember, you're doing multiplication, division on that first page. 1 through, 1 through 5 on that first page. On the next page, you're doing sum and difference. I think it was 1 through 4. Then the last problem, number 9 on your worksheet, was a complex fraction where you had to like multiply everything by its common denominator to get everything and cancel out. If you have questions, don't be afraid to ask. I'm going to make your answer keys. You guys are kind of working today. It's due on Friday. So, but yeah, that's all I got.